Alright everybody, here we're going to check out part 2 of the 4.3. We did parallel lines on the first day. Here we're going to look at perpendicular. So perpendicular lines, they create those 90-degree angles. And they're important so that we can have roads that run east and west, and then also north and south. The reason we have roads that are perpendicular, for the most case, sometimes they're not, but it's because if you can imagine, if we had roads that crossed kind of like that, so not perpendicular, this area right here isn't particularly, valuable for storefronts because it's like a tiny little corner there that's hard to utilize. And sometimes you'll see buildings on like a weird little triangle plot. But when roads are perpendicular, then we have street corners and people can have all their businesses, and houses, can fit better on a 90-degree angle than trying to fit some things in on, like a sharp little triangle. So that's why we'll see perpendicular lines in city construction, and same thing with how bricks fit together. It's really easy just to stack them. If you look at the bricks of the wall, making them perpendicular, diagonal bricks would get kind of difficult to work with. So we just saw some perpendicular lines. So I'm going to draw a couple here myself, just kind of freehand. It does create, 90-degree angles there, though, around the middle. So what really makes them perpendicular? We're going to look at that today, and part of that I'm just going to reveal here to you. But you will notice that, right here in this one I drew, one has a positive slope, one has a negative slope. Another example of perpendicular lines would be, vertical and horizontal lines, which this one has a slope of 0. This one's slope is what we called undefined. That's another example of perpendicular lines. But otherwise, if we draw lines that aren't slope of 0 and perpendicular, they will always have one positive slope, one negative slope. And you can try and draw some, they're both positive. But as long as they're both positive, you'll never be able to get that 90-degree angle in there. Or if they're both negative. So we need one positive and one negative. So what's going to happen here is I'm going to use the word opposite. And what that applies here to is positive and negative. So opposite, and then there's going to be something that's need to reveal here to you, a word called reciprocal. And that is this. If one of them was 2/3, the reciprocal is 3/2. So both of these components have to be true for perpendicular lines. It's called opposite reciprocal slopes. All right, but you'll notice there's no mention of y-intercepts here. That's on purpose. We don't need any information about y-intercepts. Y-intercepts could be, whatever. You can see I could draw another red line here that's also perpendicular and it has a different y-intercept than that red line. They could even have the same y-intercept. If I drew this line right here, these guys have the exact same y-intercept. So y-intercept doesn't have any limitations. So if the slope of one line is a positive 3/4 and I want to be perpendicular, I need to be a negative 4/3. What happened here? Well, we went from positive to negative, and I went from 3/4 to 4/3. So if the slope of one line is -4, we'll want to think of that as -4/1, and the other one must be a positive 1/4. And if I draw that, and let me do that here. I'm going to take away these guys, which I had previously drawn. And I'm going to kind of show you that slope of 1/4 and 4/1 creates perpendicular lines. So I'll just pick a couple points here. I'll pick this guy and go up 1/4 or down 1 to the left 4. So we've got that slope there. Now if I draw the other one, because this one had a slope of 1/4, if I give the other one a slope of a -4, I'll even start here at the same point, which is down 4 to the right 1, or up 4 to the left 1, you'll see that, oh wow, it does create the 90-degree angles there. So there's just a little proof for you. So now this part here is going to be very similar to what we saw yesterday. We're going to write an equation of a line that's perpendicular to that. So let's graph that guy first. Y-intercept of -1, slope of up 3 to the right 4, or down 3 to the left 4. Okay, and we want our equation to pass through 1, 2. So you can kind of envision what's going to happen here. It's going to look something like that, right? We might not have a fraction y-intercept. So we might have a fraction y-intercept. That's how we're going to use in some of our tools to help determine that. And we're going to use our point slope, which I mentioned we really need to know because it's very easy and it helps us do a lot of stuff. So if I want to pass through this point, here's my x1, here's my y1. I'm going to start to fill this in. So we'd have y minus 2 is equal to, I'm going to leave the slope blank for a second, x minus 1. So that's an equation that's going to pass through our coordinate point of 1, 2. Now I need to determine the slope. Well, if that slope is a positive 3/4, my slope needs to be a negative 4/3. Notice the opposite reciprocal there. So there is my equation in point slope form. If I wanted it in y equals mx plus b form, we would need to distribute and solve for y. So if I distribute here, we get negative 4/3 x plus 4/3. Now to solve for y, I'll add 2 to both sides. But instead of calling it, 2/1, I need to get common denominators of 3. So I'm going to multiply by 3/3 to get 6/3. So we have y is equal to negative 4/3 plus 10/3, which if you think about that, that is 3 1/3, which if we look at that quick sketch that I made, you'll notice, hey, that looks like it is crossing at about, 3 1/3, considering I just did that with a freehand graph. So if I wanted to make this picture, I could start from the point they told us to pass through, 1, 2, and use our slope of down 4 to the right 3. You can see that that one also lands, pretty much right where we expected it on our sketch. And we get our perpendicular lines. All right, so we've got one last one here. Let's get the first one graphed. Y-intercept of 5. Slope of down 3 to the right 1. We just graphed this guy right there. Now we need our line to pass through -2, -4, right there. So we're going to need to write our equation into point slope form. Here's our x1 and our y1. x1's a -2, y1's a -4. For the slope, if the slope was -3/1, we need a positive 1/3. Notice the opposite reciprocal there. So I could tidy this up and call this y plus 4 is equal to 1/3 x plus 2. Okay, So that is an equation that passes through -2, -4. I'm going to go ahead and graph it, from this because I know I'm passing that point in the blue. I can use my slope of up 1 to the right 3. When we do that, you'll see we get our 90-degree angles in there. You'll also see we get a fraction y-intercept. If I wanted to find what that fraction y-intercept was, I need to distribute and solve. So here I would need to subtract 4 from both sides, but instead of calling it 4 over 1, I need to be denominator of 3. So I'll multiply both by 3 to get that. And we get y is equal to 1/3 x minus 10 over 3. Let's check that with our picture. Does it look like we cross at about -3 1/3? Yep. So there's that equation in y equals mx plus b. So very similar to the parallel lesson, except this time, instead of the slopes being the same, they are opposite reciprocal. And we're going to cover that in the recap. Parallel slopes are identical. Y-intercepts must be different. We didn't cover that, I don't believe, in the first part, but if I have two equations that have the same slope, and I want them to be parallel, which means they never cross, they need to have different y-intercepts, because if they had the same y-intercepts, these lines aren't parallel, it's the exact same line. So if I wanted them to be parallel, I need to keep their slopes the same for the 3x and make the y-intercepts different. You have to have different y-intercepts to be parallel. For perpendicular, all you need is opposite reciprocal slopes. Right, and if you're ever going to do any kind of design or creation, engineering, you will need parallel and perpendicular lines a lot, because as we covered, it's in so many of the designs and creations that we see in the world around us.